Okay, so we're going to talk about infinite geometric series. So infinite is exactly what it sounds like. It just means that you're taking the sum of an infinite sequence. So it's going on and on and on and on forever. You're probably like, well, how can I add together infinite terms? Well, it only works if the absolute value of r is less than 1. Because if the absolute value of r is bigger than 1, then what happens is the numbers are just getting so big that you can't add them together. Like you're going to end up adding infinity. Like the numbers are going to be ginormously huge, so you can't add them together. So how can you add them together if the absolute value of r is less than 1? Well, the absolute value of r being less than 1 means that you're going to have some sort of fraction. Now, it could still be a negative sequence, that's okay, but it's some sort of ratio that's a fraction, which means the numbers are getting smaller, which means you're approaching 0, which means you're ending up adding something that's so small that it's not really changing your value. It's so negligible. So you are able to find a number that it approaches. You'll do a little bit more with this in pre-cal. So just kind of an introduction. All we need is that first term and our ratio. Notice that it's just an s. There's no s sub n because there's not a finite number of terms. So find the sum of the series. First thing we need is our a1, which we can get from looking at our sequence here, our series here. So a1 equals 1, and then we need to figure out what r is. So r is going to be negative 3/4 divided by 1, which is just negative 3/4. So we've got our first term, we've got our ratio, so we can go ahead and just plug that into our formula. So s equals a1 over 1 minus r is negative 3/4. So the absolute value of negative 3/4 is positive 3/4, which definitely satisfies that condition, but it's not saying we're not using the absolute value in our equation. We're just using r in our equation. So go ahead and type that into your calculator. 1 divided by basically 7/4, and that's going to end up being 4/7. So this sequence approaches 4/7. So we look at the next one. We know that this is an infinite sequence, infinite series. Two things here. So we've got this infinity sign up here that's telling us that it goes up to infinity. We also have, if we kind of go back to this a for a second, that dot dot dot, that dot 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 is telling us that it's going on forever. So here, that infinity, all we need is our first term. So our first term here is that 5, and then the 0.8 is our ratio. So we kind of figure that out and type that in, or plug that into our formula. So s equals a1 over 1 minus 0.8. And then that 0.8 is definitely in the absolute value of r being less than 1 condition. So we type that in our calculator, we should get that this is 25. So a couple more here. We can go ahead and look at this. It's definitely infinite because of the dot dot dot. A1 is going to be negative 1/2, and then r is going to be 1/4 divided by negative 1/2, which is also negative 1/2. So we plug this in. First, check your ratio. Notice that our ratio does check out. The absolute value of negative 1/2 is less than 1, so it's good to go. Plug it in our formula. S equals a1, negative 1/2, over 1 minus r, which is also negative 1/2. So if you type that in your calculator, you're going to get negative 1/3. All right, so this last one here is an infinite sequence also because of that infinity. A1 is 3, and then r is 5/4. So when you check out that ratio of 5/4, you're going to notice that the absolute value of 5/4 is not less than 1. So this is what we call no sum. So that's saying that that sequence is getting too big. Those numbers are going to be so ginormously huge that you can't add them. That's it.